Hi everybody. I just wanted to talk a little bit more about confidence intervals for the population mean and talk about what it really means when you create a confidence interval. So this is a simulation that's done on the internet, and it's on this website rpsychologist.com slash d3/ci, and basically it just creates confidence intervals using a random sampling distribution that it comes up with. And one thing that you can control, you can control a couple things actually. So you can control the sample size, you can control the speed of which the confidence intervals are created, so you can make it go a little bit faster, and you can also control the confidence level at the top with the slider. So 95% confidence interval is the most common confidence level, and what you notice is this dashed line represents the mean of the population. And so every time a new sample is created, this blue dot is the sample mean that's created. And if it's red, the confidence interval created from that dot does not fall within that dashed line. So we can see that most of them are black. In fact, about 95% of them are black, because that means that if it's black, it's capturing the population parameter. So watch what happens if I reduce the number, the confidence level, let's say to 80%. Let's see if we notice a difference. And we notice that the size of the confidence interval, the width, actually decreased on average. And we notice we're seeing a little bit more red, and that makes sense, right? Because we talked about how when the confidence level decreases, your margin of error is going to be smaller, but you're going to, because your margin of error is smaller, you're only 80% confident, and therefore 80% of the time your confidence interval you create is capturing the population parameter. And if we go to a really extreme case, you would never do this in real life, but let's say we went all the way down to like 10% confidence. We see mostly red, and they're very, very small intervals. Only 1 out of 10 intervals are actually along the line here, but most of them are just too small, and they're all red. Okay, I'm going to put this back up to 95%. So let's say we want to keep our 95% confidence. If we want to keep our 95% confidence, but we do want smaller error, we do want smaller margin of error, what we can do is increase sample size. And there's a cool sample size function. So right now our sample size is 5. So let's increase our sample size to like 30. And we see now every single confidence interval that's being created is a lot smaller, but are we seeing more red? And the answer is no, because our confidence level is still the same. So this is the thing I'm after here. You want to be more accurate, but at the same time you want to keep your level of confidence. Well, then you need more data. You need your confidence, or you need your sample size to be larger. So this is kind of a cool applet online you can play around with. I like it because it illustrates the effect of the width of the confidence interval. If you if you slide the confidence level, if you can go all the way up to 99, or if you increase and decrease sample size. If I decrease sample size again, my confidence interval gets wider again, if everything else stays the same. So yeah, it's kind of a neat thing. And yeah, if you want to play around with it, it's rpsychologist.com.